You flip a fair coin until you get 5 heads in a row. How many flips do you need to make on average? You are watching Brain Exploders, the world where brain starts working. We will use Markov chain to solve this problem. Let us suppose that E is the expected number of moves to get 5 heads in a row. Suppose we start flipping the coin. After a number of flips in the last, we have a tail. In these so many flips, we did not get 5 heads in a row. Now what do you expect the next flip to be? Do you expect a head or do you expect a tail? In the next flip, there are equal chances for both heads and tails, that is 50% for each. Since there is no difference between the probabilities of getting a head or tails after so many moves, and the last move is not head, that's why still we can expect that there are E more flips required to get 5 heads in a row. Here E is the expected number whose value is to be determined. It doesn't mean that there is no chance to get a 5 heads in first 5 flips, but its probability is less. Since it is possible, we will consider it in our problem. Now when we start the flipping, let's see how many cases are possible. In the first flip, we may get a head or we may get a tail. If we get a tail, then E more flips are required to get 5 heads in a row. It is expected. Now if we get a head, there is a possibility that we get 4 heads in the next 4 flips, and hence the expected number of flips are something different. So we will divide this case into two sub cases. Maybe the next flip is tail, or it is possible that next flip is head. If we get a tail, we can expect E more flips to get 5 heads in a row. But if we get head, hence in the first 2 throws we have 2 heads. Now there is again possibility to get 3 heads in a row in the first 3 flips. So we will again divide this case into two sub cases. Again there is a possibility of getting a tail and a head. If we get a tail, we can expect E more flips to get 5 heads in a row. But if we get a head, there is a possibility that we get 2 heads in the next 2 flips. Again divide this case into two sub cases, and in this way at the last we find that we can get 5 heads in the first 5 throws also, but with some lesser probability. Now let us see how many flips are there in each of these cases. In the first case, one tail, E flips are required to get 5 heads in a row. So in total there are E plus 1 expected flips. In the second case, one head, one tail and E flips are required to get 5 heads in a row. So in total there are E plus 2 flips. Similarly, in the first 5 cases we have E plus 1, 2, 3, 4, 5 respectively. But in the last case we got 5 heads in the first 5 throws immediately. So total flips over here are 5. Now let us see what is the probability of each of these cases. First case means getting a tail in the first flip. So its probability is 1 by 2. Second case means the um, second case means getting a head in the first throw and a tail in the second throw. So its probability is 1 by 2 times 1 by 2, that is 1 by 4. Third case means getting 2 heads in the first 2 throws and then a tail. So its probability is 1 by 2 times 1 by 2 times 1 by 2, which is 1 by 8. Similarly, probabilities of all the cases are shown on the screen. Now, expected value is the summation of values times their corresponding probabilities. So E is equal to 1 upon 2 times E plus 1 plus 1 upon 4 times c plus 2 and so on up to 1 upon 32 times 5. On solving this equation, we get E equals to 62. Hence, 62 is the expected number of moves to get 5 heads in a row. This was our solution. Let's move to our another question. In the following figure, O is the center of the circle. If the areas of smaller squares are a square and b square, then find the area of larger square. Try this question and send us your solution, and if you have any question like this, then please share with us. Don't forget to like and share our video, and for more such videos, subscribe to our channel Brain Exploders. Thanks for watching.